Imagine you've spent months building your software project. It compiles perfectly on your local machine. You push it to GitHub, run your tests, and everything passes. But the moment real users hit your platform, the entire production database crashes. It is a fundamental, silent misunderstanding of the loneliest concepts in computer engineering. Nothing, 0, and 1. Today, we are pulling back the curtain on hardware memory layouts and database execution engines to show you exactly how mastering the jump from null to 1 will change the way you write production-grade code forever. To truly understand data structure design, we have to look directly at physical hardware architecture. Why does almost every modern language start indexing arrays at 0 instead of 1? When you declare a raw array in a low-level language like C, your variable name doesn't actually contain the data structure. It acts as a pointer directly to the base address, the literal physical location in your system's RAM. When you reference an element, the computer doesn't count items sequentially. It uses this exact pointer arithmetic formula. Address equals base plus the product of the index times the element size. Watch what happens to the math when our index is 0. The entire right side of the equation evaporates, resolving instantly to the raw base address. In early computing hardware, eliminating that extra addition instruction per array read saved massive CPU clock cycles. But as high-level development evolved, this hardware shortcut created a massive cognitive disconnect for developers moving from memory management into schema design. This structural friction brings us directly to the ultimate graveyard of junior applications, the database layer. Let's look at the mathematical reality under the hood. A value of 0 is an active data allocation inside your database row. It represents a precise, measured state of 0. Null, however, is not a value. It is an allocated marker indicating that data is completely missing, unrecorded, or unknown. Think about the catastrophic implications for application logic. When your backend runs an aggregation query like select AVG score from metrics, the database engine completely discards null values from the calculation, but it forces numerical 0 values into the average. If your system incorrectly saves an unrecorded score as 0 instead of null, your corporate business metrics are instantly corrupted. Even worse, letting unchecked null footprints leak into columns that require indexing breaks your B-tree navigation paths, forcing database query planners to execute full table scans that slow your system to an absolute crawl. So how do you transition into writing bulletproof architectures? You must embed 3 production habits into your daily development cycle. First, enforce strict schema control. Explicitly declare not null constraints on columns that handle arithmetic metrics, mapping them to explicit default values right at the database layer. Second, embrace modern language paradigms, leverage defensive features like optional types and clear null coalescing operators to trap unallocated data states cleanly before they ever hit your core application logic. And third, adopt the mindset of system growth. Every single enterprise architecture running globally today started as a completely blank text file. Safely taking your code structures from an empty slate of nothingness straight into an optimized, highly resilient system is what engineering excellence is all about. That is exactly why we built this channel. To take your technical skills all the way from null to one. If this breakdown sheds some light on your system designs, drop the weirdest bug you're fighting in the comments below. Smash that subscribe button. And I'll see you in the next deep dive.